In this lesson, Outcome A1 Part 2, we're going to talk about reflections as a transformation. So, we already talked about H and K, horizontal and vertical translations, and today we're going to talk about just reflections. So reflections are exactly what they sound like. They cause a function to reflect over either the x-axis or the y-axis. The values that we look at when determining these reflections are the A value and the B value. So you'll recall in the last video we were talking about the H value and the K value. In this video we're looking at the A value and B value. So the A value is related to vertical reflections. This A value is going to determine if you reflect this over the x-axis. If it's negative, that's when you will have a reflection. The B value is related to horizontal reflections, or a reflection over the y-axis. If it is negative, then the graph will be reflected horizontally. So for example, in this function right here, f of x, which is drawn in black, is being used to sketch y equals negative f of x. Notice that negative is in front of the function, meaning that this is a vertical reflection. It means that this is going to reflect vertically or over the x-axis. I've drawn out a table of values if you wanted to do mapping notation, just like I showed you in the last lesson. In this case, what's happening, because it's a vertical reflection, it's changing your y values. So all of the original y values, so these values here are the points on the original graph, all of their y values are going to change signs. So we're going from xy to x negative y. You'll notice when we draw it, all that's happened is each point up here has reflected down below the x-axis. Notice that the x values have not changed. Points that have stayed the same are the points that are right on the axis itself. We call those invariant points. I've written that up here for you. Those points do not change. They are directly on the axis that we are reflecting over. So this point is going to reflect down. Here it stays the same, and this y is positive 2 becomes y is negative 2. So that's a vertical reflection. In example 2, I've given you an equation to transform. So the transformation, or the equation I've given you, is g of x equals x minus 2 times x plus 2. You can graph that function however you would like. You can graph x equals positive 2 and x equals negative 2 as your x-intercepts, or if you want to expand this function, you end up with x squared minus 4. From the last lesson, you might notice that this is just x squared moved down 4. So if you had x squared with a vertex at 0, 0, and move it down 4, you could plot this parabola. So once you've graphed that parabola, x squared minus 4, using whichever method you'd like, I'm asking you to then graph negative g of x, or negative x squared minus 4. This negative is in front of the function notation, so it represents a vertical reflection. All of the y values are going to change signs. So how I tackled this one is starting with the vertex. The vertex of negative 4 becomes positive 4. This point here has a y value of negative 3. That becomes positive 3. This point here is right on the axis, so it stays on the axis. Did the same thing with the other side of the graph, and you'll see that this parabola just flipped upside down. It's also important to label your graphs so that you know which one was the original and which one is the reflected graph. This works the exact same way with horizontal reflections. So, in this first example, I've graphed a function for you. So in black, this is the original function. And I've asked you to sketch f of -4, so to reflect it horizontally. In this case, all the x values are going to change signs. You're reflecting it over the y-axis. So any point over here is going to flip over to the other side. This point here, -1 is the x value, will become +1. Any point that's right on the axis will stay there, and any positive x values become negative. So you'll see this graph has the same shape, but it has been reflected over the y-axis. The same is true with the next graph. Again, I'm going to ask for a horizontal reflection. In this case, I've given you a parabola that's written in factored form. So remember, this parabola, the original graph, has x-intercepts at 2 and -4. Those are here. But with most parabolas, we always want to draw our vertex as well. So I know that the x value of the vertex in this case would be -1, because it should be directly between -4 and 2. -1 is right in the middle of those 2 points, so I know that that's the x value. If I plug that x value into my function, I can solve for my y value. So this leaves me with a vertex of -1, -9, which I've drawn right here. When you connect those points, you are left with your function h of x. But I've asked you to sketch h of -x. So this is a horizontal reflection. Again, you're going to reflect all of your points over the y-axis. So here we have an x value of -1. It's going to become +1. Here we have an x value of -4. It's going to become +4. And here we have an x value of +2. It will become -2. I've used the vertex and the 2 intercepts as the anchor points for this graph, because once I have those 3 points, I have enough information to be able to sketch my transformed graph. Try out the practice questions and let me know if you need any help.